we are ready to start. So thank you all the participants for your patience and also your attendance in this session. So this is the Fintech Seminar Series, and we are very happy to have Dr. Yan to give us a talk about WeBank blockchain. So let me briefly introduce our speaker today. So Dr. Yan is a blockchain security scientist at WeBank, and he specialized in system security, applied cryptography, privacy protection, distributed systems, and other leading technologies within the blockchain domain. So before joining WeBank, he also led the privacy infrastructure team in Google and obtained his PhD in information security from SMU. So today he will share with us the WeBank blockchain and trust data collaboration, technology, case studies, and future trends. So we are very happy to have Dr. Yan today to share with us this interesting topic. So let's welcome Dr. Yan, and Dr. Yan, it's time for you to share with us. Thank you.
Yeah, thanks, Prof, for warm introduction, and I'm happy to have this opportunity to share some of our knowledge and experience in blockchain domain with NTU students. So, you know, the blockchain is one of the hot topics in the world today. It's kind of a new technology. People will think we should shape the world. So I think I will bring you some new idea, maybe could be inspired how we can use this technology to change the world. And today my talk will be around 45 minutes. Sorry for the delay, some technical issue. We encountered this several times, but this time is longer than we expect. But we hope next time will be better. So let's back to the topic today. So main topic, we will cover 3 parts in the talk. The first is I'll give you a very brief introduction WeBank blockchain, because actually we have done many interesting things. Because during the limitation of the time, I put some highlight what might be interesting to you. And the second part is called a trusted data collaboration use case study. So essentially, there's some example how we can use blockchain and the related technology. So actually, when I talk about blockchain, it's not just a blockchain. So there are more infrastructure and other technology can be built together with blockchain. Actually, in this way, we can do more than what the native original blockchain can do. So in this part, I'll show you some case study to demonstrate this capability. And in the very last part, we got the next generation of physical because. The physical because is the name for the WeBank blockchain platform. So also we are thinking about what will happen in the future and how we will react to it, and what we will think is important. Also, it might be good thinking time and then for in the industry side. So let's go through the first part first. So about the WeBank blockchain. So as you know, WeBank is the leading digital bank in the world. And so in order to achieve this, we are very different from traditional bank, and the technology is very important part of our bank strategy. So since the very beginning, when we started the company in 2014, the distributed technology is always the major strategy direction we pursue. So there are a lot of work and efforts is doing to build the infrastructure to support advanced technology, for more fast-paced service and innovation. So, and we see this in the 2016, and we form a consortium we call a FISCO. The FISCO is kind of a community among a lot of major industry players like Tencent, Huawei, and so basically they are technical giants in China they work together to develop a financial grade blockchain platform. And 1 year later, we officially announced the open source the consortium chain platform we call the FISCO because. So this was our main target today, just going to show you. And then after that, we are not just working on the the infrastructure, the blockchain itself. We also work on the middleware and other up-level application support to help people to build application with blockchain. You know, only the blockchain is just a way network we can exchange data more trustly, but if we want to support more application, we need more other capability. One of the major thing, one of first important project we do is identity. It's kind of identity management. So essentially, it is the very important part for any information system for for running any real business. Then we also make more progress to get more middleware available for the developer, like the WeBank is a middleware platform for you to use the blockchain with the graphic user interface, not just use the command line, make it more user friendly. Also other things like also we are kind of in a way to incorporate other technologies like federated learning and also other privacy tech, GDPR solution selection into the blockchain ecosystem. So this is the things how we started, and so far we already the physical because and our city is already become the China's largest blockchain open source community. So you can see it's since December 2017 is almost 4 years now. Right? It actually we go quite fast actually because people are very very interesting new technology, and we are the pioneer in this area. And so far we already have more than 120 application in production. So they are not just a prototype, but they actually use it for the real business, like copyright, arbitration, finance, smart governance, and I will show you more later. And also, for the community itself, we are now have more than 2,000 participants and institution member. So they kind of work together with our open source project to contribute to the new component, to work together with us to make the technology to move better. So, and then also for the individual members, we got a higher number. And more important thing is for the success of this community, we need to help people to quickly get their hand to start their own system on blockchain. So we provide a lot of technical resource to help people, like not just open source the code. We also have the example, the document, also the tools to helping people to develop their blockchain application. So that's why we are happy to see this award and recognition. And there were some of from the top Chinese authority. Also, this year we are listed as a blockchain 50 by Forbes. I think it's also a great honor. Also from the top international consulting company like Gartner and Forest. There are two companies actually, but we just put there. So they recognize us as one of the most advanced blockchain solution provider in China. And also there are a lot of use case report to describe how we actually done it. So we are very happy to see this. And so then back to the technology itself. So what do we have done for our platform, and then what do we have accumulated during the past effort? So basically, the blockchain is actually very complex system if you consider that it is an entire ecosystem or the application layer. So far we have more than 16 code repository open sourced on GitHub, and also from the official test we achieved more than 2,000 TPS with a single chain setup. So this is actually quite high number if you're familiar with the other famous blockchain platform like Hyperledger. Usually the TPS is not that high. I would say much lower. Quite most of the time, it's if you use the default setting. And also we do produce a lot of code and also a lot of document. So if you're interested, you can look in the main entry of the open source code repository. So basically it's get under the physical because. But I will share more after that. So keep going. So what blockchain can do exactly? I guess most people may wonder when they first see the blockchain, right? So you may see a lot of examples from the financial application, like if we do the payment, clearance, like interbank reconciliation, and many because we call the native application on blockchains are most focused on financial service. But actually, this is not true. I would say not. So it's a very restricted view on what blockchain can do. So actually, in China, if you know, is actually blockchain is already part of national strategy. So in the way that's company-wise, I mean national-wise, we are making it as a new type of data infrastructure to support the daily activity. So that means can be using many more type of area. So to help people to make data to flow more trustly, and then actually to get more benefit from the technology. So here it actually lists a few typical application area we already in our ecosystem. So like the supply chain management, that we help users to trace the good, because the goods usually goes to a different party, and we need to make every party to behave honestly and don't cheating. So to detect some fraud, so blockchain was a very good fit for this kind of scenario. Also like the charity, social governments, sharing community. As long as you have a lot of party to work together to collaborate, then we think that blockchain could play a very important role to build such system, make it more trust and reliable. So I'm not going through this every words now, but I think after class we can share these slides, right? Yeah. So because we start later, but I still try to finish on time. So let's skip a little bit detail. So one of the questions I think you might want to ask is how we actually achieve this, because the blockchain, the blockchain, in order to make the consensus work, actually they have a lot of overhead. If you want to make it a large scale data infrastructure, actually we need to overcome a lot of technical infrastructure. So here's the answer for this one, because there's also the key decision when we develop a physical because. So physical because is not a public chain, blockchain. They don't use the proof of work like consensus protocol, but instead it go back to a more, I would say, the scalable, use the consortium blockchain protocol like a PBFT style protocol. And so in this way, actually, we can provide more access control and other the performance benefit when we compare to the public blockchain. We also make it more regulator friendly, because from the national wise, if you really want to be a data infrastructure, you need to be able to be used by those regulators. So we believe the consortium chain is a very good balance, a balanced choice for us, and to make the blockchain work and also provide the stability and innovation. So this could be a very different why we can also explain how we can achieve this key decision factor. And then this is kind of a full picture, but not a full picture. So this is only the open source part. We also have some progress, the ongoing project is not listed here. So you can see this. So what we want to provide is not just a single chain or a single a platform that you can put your data into the box, but we want to provide you a one-stop developer experience to build your own business application. So that's why besides blockchain, we also provide a lot of middleware, also other component to help you So like I mentioned, the VBase is the middleware platform made mainly the GUI, like graphic console help you to operate the blockchain. Also, we have V-identity is a decentralized digital identity. So it's allowed different institutes to issue their own certificate, but can be recognized by each other mutually. So this is also very different from the traditional identity, that's the centralized identity system. Also, we have a VDPR as a collection of the data privacy solution to help to address different privacy concerns when in a scenario. Also, we also work with the cross-chain part. So because it's not the only choice, because the existing system may already running on other type of the blockchain, but we still want to be interact with them they don't have to rebuild their chain or replace their existing system, but they can use vCross as an interchain interoperability to connect this information from two different type blockchain. Also, other things like the liquid, the smart contract, it's more like a Rust. If you're familiar, Rust is it's a new type of system language, and we believe it's have a very good safety feature to help us to write a more secure smart contract. And also the compiler can do a lot of check for you. Also, other thing like the data governance, collaboration governance, event collaboration, also the data oracle to help us to fetch more data from outside the blockchain into the blockchain. So in a way, we can deliver the trustiness to expand our network of the data, the trust. So also have the other template. So in a way, we can build different type of application on that. So this actually is all we offer now, and all the project lists have their open source part. So you can go to the WeBank blockchain. So I will share later. So if you're interested in this work. Now we go to a more concrete example on what type of the application can be built on this kind of the collection of the technology. So this is what we call the trusted data collaboration case study. So come on. Okay, it's better. So okay, then we move on. So the basic idea is that when we think about what blockchain can do, the short answer is just to keep the data, to use the immutability. I mean, it's a read-only database, right? So if you're familiar with the early history of a blockchain, so this is why people will think it's more trusted data storage, because once you put data on that, you cannot change it. Especially we have multiple parties to do the collaboration. And if we want to change it, you will leave a trace. So in this way, we improve the trustness of the data source. So this is the basic idea when we talk about the blockchain. But this is just the first step. So what is important is that we think is more important and more valuable or more impact direction is next step. We want to use this as a base layer to facilitate the trusted data collaboration. So essentially, I mean, we will have a more secure digital identity, and we also have a more trusted way to exchange data. Also, we want to use data to some computation, but in a privacy-preserving way and a more friendly way. So these are the new technology capability we are developing, and we're going to show you in this part. So let's move on. The first part is more the digital identity and the trusted data exchange, and how blockchain can help on that. So there are two key questions here. Then the first thing is, what will be a secure identity system you're considering a distributed manner? So in a traditional way, we have a single issuer to help you to issue different certificate, but with different issuer, how they can trust with each other. And this is a very typical blockchain thinking what so this is how blockchain can fit, right? And also the next question is what do we need to fulfill when we want to exchange the data more trustfully from one party to another party? They don't trust each other, or they may deliver it to a third party. So they will cause a chain of the data exchange deliver. So how to keep a trail, the audited trail for this data integrating, for people to verify the data is indeed is not be modified. So this is the key purpose for this two part. So then this is the existing pain point, and I mentioned some of it. So first is when we actually talk about the digital identity, that the first challenge is we have a lot of standard, right? We have a lot of standard, and usually they are not compatible with each other. And then it's just cause a problem, right? We want to the certificate issued by different party to be recognized by another party. So gradually we have this new effort, an international effort we call the DID initiative. So to help us to address it, and also our solutions also follow that specification. And the next thing is about the data leakage risk, and other things like the lack of authentication, and also the data integrity list. So the way this is the same in the concern when we actually want to exchange the data, and we need a solution to help us to address this kind of a concern. So that's why we have the V-identity. V-identity looks like an identity, but it's more like e-passport. I guess this may be easy to understand. So basically, we will create a decentralized identity, and also the capability to attach the data to that identity. So that way, if one organization can issue the certificate for identity, and also they collect all the evidence or the other data, and this data can be verified by another institute in a distributed manner. So this is what exactly the V-identity can do, and in the way we can also can exchange or deliver data in more trusted way, because every data is associated with that identity, and the process that we can use the blockchain-based audit trail to ensure the data is the same when people actually sign the data, and when people also receive the data. So this is the basic idea behind this technology. So we have a hash and a signature to this kind of system. So if we look at the detail on what exactly for the specification to enable this kind of we call it the standardized, decentralized digital identity and the data transfer. So it's called a DID. I mentioned before, the DID is for decentralized and identity. So basically, it's under W3C organization. So this is international effort. So this is the typical schema when you look at the DID. So it's always start with DID. The next part is the example, is the method. The method means it could be different domain. Like VID could be one of the method. Another provider could be another method. This is a kind of hierarchical way. And the third part is the DID method specific string. It's more like an argument. If you study computer science, you know this. The method with the arguments, you can do whatever you want. So basically the idea. So it's very concise, very simple design. If all the people follow this one, then they can be compatible with each other to do the work. So look at the full in the credential when we use the VID the document. So remember, we always start with the DID part, and then VID is the method. And then you can have multiple sections here. Then this is a Qiang ID. So basically, you can specify this is VID issued by a particular chain, and the Qiang 101s, and then other ID string, and just the kind of argument. So this describe who the exactly ID is the address. So this is the full identifier, and you can see the full ID is appear here. So this is work like index. is how also like we think it is a passport. This is the identity of the passport. But the passport itself not just about identity, it also have other information. Then you see the public key. The public key is one thing we can actually verify many the like signature signed by this identity. Also, we have the endpoint. So this is the endpoint, and you can work together to do other verification work. So this is the general idea on what VID works. So you have ID and attach with the data. So in the way we make the decentralized identity work. Also, one interesting thing about DID is that it's not just a signature verification. I mean, not in the credential, we are not just sign plain text data and all other people just verify the signature. This is a more traditional PKI system, right? PKI stands for public key infrastructure, like what we have for this for most of the information system used now. But the DID actually have very interesting design. They call it claim. The claiming is you can claim certain attributes to satisfy certain condition, but without review it. So that, for example, when we go to the hotel, in a traditional way, you want to show your ID card, and also you may attach a signature from authority who actually signed the ID card. So in the ID card actually contain a lot of information. I remember in Singapore, it's also have your fingerprint, right? So I was studying in Singapore. I remember that it's your fingerprint. I don't remember whether they have a resident address, but some ID cards have a resident address. There are a lot of private information you don't want to share with others. But with DID, we can do better. So essentially, it does not just allow you to present the original card, but it allows you to generate a claim. The claim could be a proof. The technique behind it is actually the zero-knowledge proof. You can prove when you go to the hotel, then your age is large and your age is older than 2021. Then you probably can have your own room. So you don't have other people to be with you, right? So that's all you need to provide. So just a proof, and people can verify the proof, but with this DID infrastructure, and they don't need to be centralized. It can be different part, as long as a recognized. I mean, in the list, you know who actually issued it, and then you can verify that the claim is correct, and you're old enough to stay alone in a hotel. They let you to check in. So this is the interesting part about the DID. And here I showed a case study. So essentially, this is one of the benchmark application of the VID. So we work together with Marco and Guangdong. So basically, we know the COVID-19 virus changed how people's lifestyle, right? They put a lot of restriction on travel. So every time we cross the border, we need to provide a lot of proof whether we are negative now, we are not a positive, right? So we are negative on the virus infection. So in this way, it actually creates a lot of trouble, because the medical data, the healthcare data is one of the sensitive data, the most sensitive data in most of the country. So how we can exchange the data more smoothly, right? So the question here is we cannot just let the data to direct to pass from one server to another server across the border. This is not allowed. The regulator will not allow. And also we need to prove the user actually do provide a consensus to agree to share this data. So in this way, the VID work perfect on this scenario, because remember, VID is e-passport style identity system. You can carry your data, and the other people can verify the integrated with those data would also to verify this is valid and true data. So in this way, we make the system with between the Guangdong and Marco, and so far it's almost close to 100 million citizens has used this this technology to cross the board. it's much easier than they bring all the paper document. The only thing they need to show the QR code at the front end page, and all the data will be transferred directly through those QR code and verified by blockchain and VID technology. So this is the idea, but there are lots of complex issue behind. But I just shared idea because like a VID can be used as e-passport to help you to carry the data cross border. So this is the key takeaway here. So let's keep going on. So let me move to the next part. We got the privacy preserving computing, and yeah, so this is also very important because we are not just move data around, right? But we also want to use this data. We want to do some computation, to do machine learning, to do data mining, right? So to extract more value on that. So then they actually create a lot of question, new problem like that. How can we protect privacy during this time, right? So there are a lot of sensitive things we don't want to expose, and also how this the new collaboration will affect all the normal business model, because the data could be confidential within a company. Whether blockchain can help on that, or other technology can help on that? Yeah, the answer is yes. Yeah. So let's keep it going on, and then very to see a very significant change recently. You see there's a in the older way, the privacy law, I mean, like in Singapore have a PDPC, right? So basically, before this kind of law and regulation take effect, and the life could be simple, because most of the time the data ownership is not very clear, and everyone get the data, they can do most of the things they want. But now it's different. So those data, especially the personal identified data, they always owned by the individual who actually generated it, no matter who collected it or not. So in this way, the relationship between the data producer and the data consumer had changed. They used to like a buy relationship. It's not, because every time you collect it, you may pay something, you may not pay something, but you don't need to worry about it because the ownership will fully transfer. But now it's more like a borrow. So this will change the business model, because even you got the data from user, you are not actually owning it, but you just borrow from the user, and the user still have a lot of right to restrict the usage of this data. So that's why we need a new technology to help us. So, and in this way, we were encounter a lot of pain point when we designed to actually the system. There's a three. Sorry. Okay. So there's three key objective. Here is we want the process to be fair, because a lot of multiple as computing consumer and provider, and also we need to handle the big data. Also, another thing is we want to prevent the data abuse. So because if you're familiar with the regulation, is that if something bad happens, they will have a huge fine for the company. So it's better to prevent it instead of we do other things after the incidents happen, right? So this is a very important thing. So different parties have different concern, and we are not able to simply address this issue with a single technology. But instead, we also need a different technology to help us to address all of them. So here's the three typical technology we are looking at. The first is the TE. It's more like Intel SGX. It's more like a black box. So basically, the idea is you assume that the hardware create a secure box for you, and you put all the data inside that secure box, do all the computation, then it's all generate the output. That's all. But you need to trust the hardware and all the other things to guarantee the security of this hardware. So this is easy to explain, but actually hard to enforce. This could be have seen. Also, it's very costly if something wrong with the hardware. And the second technique is called federated learning. So essentially, it's more focused on model training and inference prediction, and But for other tasks, you will need a more general solution like MPC, look at the secure multi-body computation. So you also, MPC have a stronger security privacy feature than typical FL, the fair learning algorithm. So, but they also have sometimes they have some performance issue if you, especially for complex computation like model training, they might be slower than further learning, especially handle the big data. So quite often we need to make some choice between them for different parts. So during the limited of time, I can just skip some slides. There's some, but you can read it later. So explain how things work behind this technology. Then we move to the next part is about the VDPR. So VDPR is our effort to build to a collection of technology to help address this privacy concern. As I showed before, you cannot rely on a single technology to solve all the problems. So we need a toolbox like a Swiss Army knife, right? So for different problem, different technology, and different solution. So we organize stuff in 3 layers: so library, the workflow template, and application template to help us. So let's skip some not very common material. So let's show a few number. Okay, this is very interesting because this mainly the performance and the function number highlight from our system. So let's see the first is 3 minutes. So basically, this, okay, I guess it's okay. There's some mistake on that one. So basically, in the process when we do the joint computation from different parts, the first thing they do is to align the sample that the data set. They want to know which data they want to find the commonly shared data. Then can they do the computation among them? So in this process, they call the private set intersection. So we made a lot of effort and also incorporate the latest achievement from academia. So we significantly reduced this kind of alignment time from 30 minutes to 3 minutes. There are a lot of engineering challenges behind that. Also, like we want to do some computation, joint computation among different parties, like 10,000 multiplication is also one of the common matrix when we evaluate the performance. So the typical value could be 100 milliseconds, but we can do less than 3 milliseconds. So there are a lot of we are doing much faster than what you can do on typical system. So yeah, that's also from the blockchain side. Like a confidential transaction, we put the ciphertext record on the blockchain. And then usually you only get less than 1,000 TPS, but we can achieve above 4,000. Yeah, they also, we make optimization on our zero knowledge part to make it to be lightweight and also be valid to keep this security feature. So I will skip these things, but I'm going to tell you more concrete example. Maybe you have a better understanding on what this kind of computation can do. The first is we call it confidential payment. So you may already know that the traditional, I would say the native blockchain, everything is in plain text. If you keep a ledger to all the payment record on the blockchain, so everyone can read it. So this is not good, right? But if we keep everything on the ciphertext, we encrypt it. Not everyone can read, but we also cause a problem. We don't know whether people will do some double spending or other attack to manipulate, to attack this kind of a payment system to create new money from nowhere, right? So this is also the same. We want to use the neural knowledge proof technology together with the blockchain to verify all the transaction on the system, and also make the payment system work. So they don't have to review the payment detail, but other people who are running the blockchain can still verify the validity of this kind of transaction. This is the first use case. And the second use case I'm going to show you about the voting process. The voting is very, a common activity and also important in your social life. This is actually achieve 3 goals. Usually think it's very hard to achieve. The first thing is the voter are authenticated. So like traditional anonymous voting, I mean the identity of the voter is unknown, right? So that's in this way they can vote for whatever they want. But in this system, the voter's identity is known and it can be verified by the service. So in this way, we can make sure all the votes, all the ballot, the opinion will be valid from a valid voter. Then the next effect is that what they vote actually be hide. So even the counter, the counting service cannot know which the individual opinion in the system. And the third effect is the whole process publicly verifiable. It means you don't have to go to each voter, each counter to ask them what the secret they use to generate this ZKP and other secret data. You only look at the data on blockchain. You can verify the whole process correct. I mean, all the ballot voted by the voter have been correctly aggregating the final result. Also, each counter do their counting honestly. So because all the process have been keeping to the ZKP, and then they can be verified without a review of the secret data. This is a very interesting application. And also the next thing is also the last example I'm going to show you is for data outsourcing, algorithm outsourcing scenario. It's quite often, there's like a fintech scenario and other scenario, and you need to get a lot of data for your algorithm, right? You get a lot of the data for your algorithm, but you usually don't have the data. Data is owned by other party. But then the interesting happens you in the old way, you have to give your algorithm or your machine learning model to other those data providers, let them to run the result. You just get the result for you. But the problem is that the model itself quite often considered as expertise is kind of an important asset of the company. You don't want to just share your model with other data provider because they may sell it to your competitor. You get a lot of concern this way. So this will affect the collaboration. And also the third part is even I trust the data provider, but we don't know whether the operator they're using the wrong configuration of the system. I mean, I may give it in multiple versions, but you just use the wrong version. But then, because every time I can only get the final result, we don't know whether I get the right result from this kind of the task. Like a lot of things like a credit evaluation, and the risk do not happen immediately, but it will happen eventually to lead to a real financial loss. So this is quite a complex problem if you look at the details. So they have 3 requirements, right? So that if the model provider don't want to share their model, data provider don't want to share their data. And when they do joint the computation, they want to make sure, especially the model provider, the algorithm provider, make sure that the data provider using the correct model and also using the correct data. And we can do this without the multi-party computation and the platform. And also there's a concept called a malicious model. This academic term we can use it to do the abuse prevention. If they use the wrong model, they can be detected immediately. And everything can use the blockchain as to keep all the trade to make things much more efficient and for a batch system. So this is the last thing I'm going to show you, and we can move to the last part. So we have 5 minutes, so I'm going to move a little bit quicker. So what will be the future? So so the first thing is we believe blockchain is not just to keep some ledger and to keep some financial data. We actually, as a public infrastructure, will be able to hold more data to support more application. So we will see a larger scale data, much larger scale data that's hosted on blockchain in the future. And also they may expect a higher QPS also a larger scale of network, not just like a current consortium network is like dozens of, I would say, not usually not more than 100, but in the future, we may have a mixed mode and a sharding to support thousands of the node to the more participant in the blockchain network. Also another thing, like keep the data forever, right? So, so for more than 100 years, so there are a lot of things happen when the scale of the system, and also from application level, we see very different type of application will be run on blockchain. And so this may require different capability we offer. And sometimes we need to make the systems itself more modular. But we not provide everything, but it makes it more configurable to make it to exactly what they need then to support the system. This also, we think, is a very important trend for the future blockchain, is a more configurable system. Also, at the last part, we are see more product participant is now got more interested in blockchain technology. It's not with Jiker and earlier pioneer, but we now see a more domain expert, research consultant, even the decision makers looking at the blockchain. We are very happy to see this one. And then, so in a way, we think it's a very important move with we need to help people from the interesting topic they do, and they can do contribute. So the ideas that we are kind of forming the special interest group for those focused participants. Some people may be interested in architecture, consensus, smart contract, and then very different topic. So in the way if there will be, I believe there will be more valuable to focus on what they really want to do, and they can do a lot of things in this book. And also, this is also the strategy when we develop an open source ecosystem. So, and yeah, this almost end, and this is a slogan. We say that together we become greater. So it's like the blockchain, and the more party join the network, we can make system more robust and more trustworthy. So this is things we want to achieve, and then we hold a lot of events in the past, but now it's very difficult because of the virus, right? So, but still we hold a lot of virtual events. So if it happens, we are very welcome to join us. And also, this is the last slide I'm going to show you is this QR code for the WeChat official account. So most of the content are in Chinese now, but I think it will not be a problem for Singapore, right? I believe a lot of you are familiar with, you're capable of speaking multiple language, right? So it's not a big problem. And also, but we do have an English version, like a document, all the technical document, we have an English version. You can look at the GitHub. And also the Fintech portal, there's a lot of, the financial grade, the solution and the demo you can find it. Okay, I guess that's all for today. Okay, 1 minute.